To everyone now, to the webinar Kubernetes for product owners. My name is Van Schubert. I'm from Giant Swarm. Giant Swarm is a company that runs Kubernetes for customers. So for example, like Adidas, they've got their web shop and they run that on Kubernetes, and we run the Kubernetes for them, the Kubernetes infrastructure. So when there's a hype sale or a different activity, then that actually scales with them, and that's where we get a lot of production knowledge and experience. We have a whole team of engineers that take care of that. And we do the same, for example, the Magenta speaker from Deutsche Telekom, or Jingo from Orange, or for Vodafone for the DXL layer, which is basically the area where if you actually access a Vodafone customer and you access your app and whatever, everything data that goes and needs to come from the backend system, that goes through a layer where we run Kubernetes for Vodafone. So there are many different use cases. We've got lots of experience, and that's where I've been speaking a lot with product owners, and where the idea came up to actually speak about Kubernetes for product owners specifically. I know we have a very different audience here today, so yeah, it'll be actually interesting also to pick up on the questions and see if I can address all your needs. Good. So typically, you actually have run into Kubernetes, or at least the cloud native stack, as a product owner. When you actually are talking, let's say, about replacing your legacy apps. So you actually have apps that are monolithic, that or yeah, huge application landscapes maybe that are on premise, and you actually then find that it actually, there's a need to run it in the cloud. There's a strategy to run it in the cloud, or even you need to upgrade your data center and find that difficult, and that's where you need to move it into cloud. So there are many aspects where when you replace apps, you typically consider bringing your apps onto a modern platform where you then can switch from one cloud provider to another, or you can switch from cloud to on-premise and the other way around. So where portability becomes very important, and that's where cloud native in general, which is a framework developed to develop applications in a different way, where you actually have microservices that take over parts of your application and your tasks, and they run then in containers. And these containers can then be moved around. So you then are very independent from the underlying infrastructure, and that's what you then call cloud native, and that's where Kubernetes comes in. Naturally, also part of the cloud native and Kubernetes area is that you've got resilience. So basically, if something goes down, you actually have a system that monitors it and brings it back up again. You've got scalability across cloud, and so on and so forth. So basically, you actually have different possibilities that you so far would have had to develop independently for your legacy system. Another area in the brownfield development is where you have you try to get rid of technical debt. You might have an application where certain architectural decisions have been need to be revised, or where you want to break out an element within your application that then needs or actually it gives you headaches, and you actually want to replace that by microservices. So you actually can then individually and successfully build your legacy applications in microservices, or at least parts of it. That's the approach that Adidas, for example, took. Is they actually split out different elements of their web shop into microservices, and are still running the core. So this is a very frequent strategy used if you actually already have an established product, and that's where you then can increase the resilience. For example, if you want to make changes to very volatile parts of the application that then cause breaks in other parts of the applications, you can actually break them out and update them independently. So you can then evolve more rapidly in the environment and make sure that you're development teams can accelerate their time to market or their innovation rate far beyond what was possible so far. In the greenfield area, where you typically always would run into cloud native development, but I'm pretty sure there are some areas where it's less frequent. But two very famous use cases are actually when you actually have new digital products where time to market is important, minimal viable products. You actually don't want to take care of all the individual aspects of the development of the infrastructure, but you want to make sure that you can develop very quickly a solution and bring it out to the market and test it, and then understand if it actually solves a pain within the customers or not, and if it needs to be adapted. And that's where the rapid product innovation comes in, where you try to ship out features very quickly, and then go into that cycle where you build, run, and learn, and then bring back that knowledge into your software development team, and then make sure that new features or features are adapted, or new features developed that customers are using, and are more likely to make your product sticky to their customer needs. So that's where basically you typically would run into cloud native development. As you actually have signed up for this webinar, I'm pretty sure you're very familiar with the cloud native benefits. I'll still walk through them. So if you actually look at the improved resilience, that's where you actually can make sure that if an instance fails of your application, then it automatically starts another one, making sure that the application stays up and running at all times. If you run an upgrade through to the infrastructure, it will be a rolling upgrade. So there's no part with no maintenance window. You can do everything on the fly, and everything stays up and running for your customers. So that's the main part of and the idea behind cloud native development. And also you can update each service independently. So when you actually see something broken, then you can fix forward and make sure that the problem is resolved very quickly. Another aspect is naturally the scalability. So you can scale up and down, so you can use the resources that the cloud providers can provide to you. You actually can save cost by using spot instances, for example, where you've got a bidding mechanism starting at 20% of the original cost, and then it goes up depending on how many resources are available, especially for applications that are more in need at night. That actually is something that can pay off quite substantially. Naturally, your infrastructure needs to be capable of using a more of breathing, let's say it that way, and your application as well. And then you can actually use it in private and public clouds across different clouds. If you actually run your applications across the world, and you might have a public cloud provider in, let's say, in Americas and Europe, and then in China you might use a private cloud provider. So yeah, there are different elements where it makes sense then to think about multi-cloud deployments and being able to use and develop the application only once, but then deploy it to many different infrastructures. And yeah, and then naturally the most important things for product owners are the speed of development. So how much time can my team focus on innovation to make sure that the features that are needed by or at least from my perspective, are needed by either the stakeholders, the users, or provide the most value, are reflected, and that's where cloud native technology can naturally help with providing a substantial bit of the stack that you would have had to develop otherwise. Authentication, security, networking, all aspects are being taken care of by the infrastructure, and that's where you can then focus on what really sets you apart, and the elements in your application that sets you apart. And the last two aspects are, from my point of view, the most important ones for product owners: the faster time to market, so you actually can bring out features and new products really rapidly, and test the waters, and also improve the agility, so you can then really have teams deploy changes very rapidly, independently from each other. Just to give you a couple of examples, there are a number of customers that actually, or companies that came from deployments like 2 or 3 times a year, and now deploy several times a day. The more agile companies like Facebook and so on, they actually have probably about 5,000 deployments a day to the Live platform. So that is definitely a benchmark that you could think about, and there's, the truth is somewhere in between. So whatever provides value to your team, how much, to your customers and to your users, naturally need a certain amount of users to make use of that many deployments. That's where the infrastructure can help a lot. To make sure that it actually directs traffic, certain groups of users to one area, so you can do A/B testing. You can make sure that that you can deploy very easily fixes that give a bad user experience, for example, very rapidly. These are all elements where cloud native technology can help, and where Kubernetes, as the core and the heart of such a cloud native environment, can really work. So if we actually talk about cloud native and Kubernetes, I actually like to use that overview where you basically have a separation of the different layers that you typically have, and why you use it. So probably to start at the very top, you actually typically break up applications in the cloud native environment into different microservices, and these microservices then handle certain elements and activities in your web environment or in your application environment, like payment or checkout, or other aspects, sign-ups, for example, where then individual teams can work on these elements and then deploy these independently and run them all by themselves, which basically supports the DevOps model. So development and operations are together, and I can only do that if I have an environment as a development team. I can only do that efficiently if I've got an environment that gives me a lot of capabilities to run and take responsibility for that without having to deal with the underlying infrastructure, because that's something that naturally takes time and takes energy to figure things out. If let's say, if my physical infrastructure doesn't work, some memory or some storage doesn't work anymore, that's where you've got the abstraction layer. That's where the physical layer comes in, where you've got your data centers, typically provided by public cloud providers or on-premise, and where you have operations people that immediately have built up a huge and very comprehensive system of detection of where certain elements might fail, memory or storage or electricity or whatever. Then security becomes an important aspect in the physical infrastructure. And these are the different basically server and racks that you have, and that you can naturally also purchase and rent, but typically they are abstracted by a virtualization that Amazon or Azure or Google provide, and this virtualization then allows you to book certain machines with certain memory and compute power, and these can then be provided to you but that basically then requires you to still install an operating system and to manage everything on top of that, and that's where basically the infrastructure layer comes in, that we call Kubernetes. Kubernetes as its core. Is a project that was developed by Google many years ago. I think it was started in 2008. It was then released 2014 to open source world around the Cloud Native Computing Foundation, and since then has prospered tremendously, and by now is the de facto standard for container orchestration. So to be able to run your microservices independently from the underlying infrastructure, what you do need is you need an environment where you can install these microservices without the need for installing, taking care of operating systems and networking and other aspects, and that's where these containers do. They take care of this element of to provide an environment for your microservice to live in. And these containers then can naturally be installed on your service, but since you actually would typically have many different microservices and then many different iterations of microservices, that's where it becomes really challenging to manage that manually. And that's where Kubernetes provides tremendous value. I've got a different separate slide where you basically can see what the infrastructure, the microservice setup of I think Netflix and some other provider look like. It actually basically looks like a Death Star there, at like thousands of microservices, and then you've got thousands versions of different versions of these thousands microservices, and you need to orchestrate everything. Doing that manually isn't something that you want to do, and that's why you actually have Kubernetes to automate a lot of that element and provide you with the different levels of on different aspects of services that you can reuse at the container levels, like security, making sure that you actually have load balancing, that you've got ingress controller come in, so ingress incoming traffic being routed to the right location, to the right microservice, being able to create connections between the different microservices, and then naturally understand, monitor everything, alert you if something goes wrong, and so on and so forth. That's all these elements don't need to be redeveloped in these microservices. They are provided by the infrastructure layer, and that's marked as an orange space on the right-hand side, where you basically have the level of the data center, and then goes all the way up to the project and teams and platform team. The platform team typically takes care of automation, so CI/CD pipelines, for example, of development teams and so on. It can be a platform team or a single person, depends on how big your project is. And then naturally, you've got a project team that takes care of your different microservices. And everything in between basically should, from our perspective, be handled by Kubernetes and its related projects. So Kubernetes doesn't exist all by itself. There are lots of other technologies that go with it. So you need a Calico, for example, for networking, a Flatcar for the operating system. You need, DNS for routing your traffic, Docker for creating the containers, etcd, which is the database for Kubernetes, ingress controllers like Nginx that then basically allow you to define rules for the incoming traffic. Then you've got Vault for secrets management, Prometheus, for example, for the monitoring. So as you can see, there are many elements that go into a cloud native stack beyond Kubernetes that you would have to take care of, and that's why this webinar is so important, because it's very important to understand what actually, it's not just do I buy a red or a blue car, and it actually doesn't impact you. It actually impacts you tremendously, because all the things that you need to do to keep it running, to install it, to keep it running, to evolve it, to identify an issue, to set up alerting, all things you need to take care of either yourself or you've got someone externally to do it. And in many projects that especially start off rather small, I see it over and over again that teams actually start off doing it themselves. So they may start EKS or whatever from Amazon, and then they manage it themselves. Which, you know, for a development environment actually isn't too difficult. But yeah, if you actually then go into production, that's where day two operations hit in and kick in, where security becomes important, where you need to think about upgrades, where you need to manage and monitor everything. Yeah, you need to set up alerting, you need to set up shifts for 24/7, and so on and so forth, that then basically eat into your budget. And it's not too much the cost budget. That's something you can control, but it's actually into your software development effort. So software developers would then basically take care, and they would spend time on tasks, which then basically takes time from your user stories, and that's where it becomes really important for product owners to really understand what Kubernetes means and what it actually can impact, and how to actually be a more vocal element in that discussion about technology and how to implement that technology. As you can see on the right hand, I drew a little arrow that shows, you know, that like, let's say data centers and the physical infrastructure is something that is very, very generic. So it doesn't provide a lot of value in terms of differentiation. Running your own data center might cost less or more depending on what kind of applications you run and how you actually basically perceive the future of your company and so on and so forth. So there are many aspects that you know, you can naturally have a discussion, but it actually won't help you set you apart from your competition. Same for Kubernetes. So yes, you can actually do everything yourself, but you also could use an external provider to do it for you, because the level of differentiation is rather minimal in that area. It's becoming a commodity, where it really makes a difference, where you provide value. If you actually are thinking about where you can spend, or your team can spend the most, or create the most value for the organization, that's where the top part comes in, where you think about the microservices and how much energy and effort you can put into innovating around the digital products that you have, or even replacing your legacy system and other things. That's where speed is important, where dedication is important, and anything that you can keep away from your project team so they can focus on what actually really sets you apart, is something that that's why it's so important for you to understand what Kubernetes is about, and yeah, and how you can actually steer the decisions and understand where the stakeholders are coming from. So I hope that concept is understood so far. As you know, if you actually need, I can always go into more detail, but I would recommend I'll go on for here, and then I can actually dive in a bit deeper in a session. You can just give me a call, and I can actually explain some aspects a bit better and in more detail. So here actually we've got the life cycle. So when we actually talk about all the things that need to get done in the area of Kubernetes, we actually think about it as a life cycle. It's an ongoing life cycle. So you're never done with the cloud native stack. It's constantly evolving. It's actually one of the fastest evolving projects out there, and yeah, and it's there are so many contributors that are constantly evolving the functionality of Kubernetes. We typically install about 30 components on top of Kubernetes to make sure we actually can provide customers with a cloud native stack that they can readily use. But then there are naturally other apps on top of that that you can use Instana might be for monitoring, or you've got Kong for API management, and Kafka for moving large data quantities of data. So there are many aspects that you can basically extend your cloud native stack with, depending on your specific use case. But let's say the basic stack is about Kubernetes and about, let's say, at least 10 to 20 components typically. More sophisticated one would have about 30 components that need to be installed, they need to be tested, they need to work together very smoothly. Some of them create issues. They need to be secured. And that's where you've got role-based access and part security policies that need to be set up and defined. And then you might install further security apps, so you need to evaluate those. Then you need to think about how to manage that environment. So how do you do the knowledge transfer from those who actually run the platform to those who develop the solution? Typically, that if it's the same development team, naturally that is not too much of a problem, but then the resources that basically set up that platform will be frequented more by those who are developing the applications because they are the bottleneck basically of knowledge in respect to the platform. Then you need to have retros, think about all the things that went wrong and how to fix them. Then you need to do upfront planning. Let's say if you actually go into the future and you've got hype sales like by Adidas or whatever, then you need to plan for that because auto scaling isn't fast enough. So you need to scale up in advance. And you also need to support if something goes wrong. So the management aspect actually takes quite some time. The monitoring aspect, yeah, you can actually set that up quite rapidly, depending on what solution you actually take, but then you still need to do the monitoring, which isn't like very time consuming per se, but you need to make sure that you cover the 24/7 shifts. So you actually at least need, if you do it yourself, you need 4 or 5 people that can rotate in shifts so they can take over. So that's already like quite some work, and it also takes away time from your innovation rate. Then when there is an issue, there might be like a week or 2 weeks where there's no issue. So you actually might spend very little time on that, but then you might find a serious issue that you need to do a post-mortem on and go and fix it. And that can sometimes, create a workload of 2-3 people for a whole week. So that's where, it actually becomes quite, you need a team that is big enough to then be able to focus on that and fix it and get done with it. So you can then basically resolve the issue and provide the uninterrupted service to your customers. And then naturally the upgrades. So there are major versions every 3 months from Kubernetes. The related projects also have many upgrades. Typically there's in the whole stack, there's a new upgrade or a new version available every week. And then there are security fixes that then need to be patched and upgraded. So yeah, you actually will have some time and activity going on. So what I put into the dark blue dots is our, let's say, minimum estimation of how much time or FTEs you will actually need. And that's also verified by other sources. So it seems to be pretty realistic. If you actually run, let's say, 1, 2, 3 clusters, then you actually should calculate about time for that, for running the infrastructure, but it naturally grows with complexity. So if you look at companies like Zalando, whatever, they've got 10 people running the platform, the Kubernetes platform for them day in, day out. So yeah, and it's basically a website and online shop that they provide, and naturally other aspects. But yeah, that's basically if you compare it to a large organization with many different businesses or business streams, then yeah, that actually is quite a significant team and it shows how much time you can invest in that area without installing and building that up. So yeah, I actually hope that gave you an overview of let's say how much time can go into managing an infrastructure, and that's something that typically, if you take a decision to go Kubernetes on Kubernetes, and it's why it's not a technology decision only, it's also a decision why you need to get involved, because these things, no one will plan for them upfront. Everyone will say, well, we'll just install it, and then step by step, your developers will be drawn further and further into managing the infrastructure, which then basically results in you getting less and less done, and that actually impedes your goals of spending your resources wisely on the most valuable task. So there are different aspects and different operation models, I call them, for Kubernetes. So basically, you can run everything. It's open source. Everything's open source. You can download it. You can start immediately. You can configure everything. You can do everything yourself. And there are actually some companies that have decided to do that themselves. This it works actually great if you've got a very special use case, and there's no provider out there that can provide that, or it actually is becoming a key differentiator for you because you can resell that service to other customers, or you actually have an environment where it actually where you've got a great operations team and you don't know what you will do with the operations team, then naturally that's there are certain situations where you actually where it would make sense to, or at least I would find also value in doing it internally. Other than that, typically companies would tend to look at public cloud providers. That's very, very easy to use. So basically, you can spin up a EKS, AKS, whatever cluster very, very simply, and that's actually part of the addiction. So when you actually have started off, you move your workloads in there, then you notice, oh well, I need this and the other one. I need some security, and I need some networking, and I need some monitoring and some alerting and so on. And then you need training for this, and then you need licenses for this. So that's where basically where it actually starts very, very easily with Kubernetes for a development environment that may make sense. For a complex environment with many, many different clusters, you actually just need to consider if that actually is the best choice, especially considering that you're actually typically bound to a certain public cloud provider. Then if you already are dedicated to AWS and or Azure or whatever, and will never leave, then and don't want to have a data center or don't have a need for that, then naturally that makes sense. If you actually want to be cross-platform, that's where the container management platforms come in, and that's where companies like OpenShift or Rancher or whatever actually have their stake, where they can then provide versions of their tool that actually work on different cloud platforms and use the built-in capabilities of these cloud platforms, like networking or whatever that the cloud platforms provide, and also on-premise naturally for the on-premise technologies like VMware and so on. And then the most important aspect is that you actually have, these are called managed, interesting enough, because what they actually do is they provide you with upgrades and so on, and a support line, but you still need to manage it yourself. That's why both of these columns actually have a quite significant internal team aspect to it. Yes, they might be they might be able to use, or you might be able to use them quite quickly, like with a public cloud provider, but you actually need to consider that they actually will eat into your budget, into your development budget, and take time away from your development tasks and your backlog. So that's just something you need to consider. And then there are solutions that we actually believe in, and that we, for example, provide, which is a fully managed environment where we operate our own stack that we have developed together with the open source community, and where we basically constantly extend and automation and setups and everything that basically we see in production goes back into the product to make sure that no customer runs into the same issue that we already experienced, and that's where the fully managed service comes in, where you still might need an internal team because you want to know the underlying infrastructure to then best design your applications going forward and your microservices, but it actually is something that you don't have to worry about at all, and that's one of the aspects where yes, it actually will cost money, but it actually will also free up your development from having to focus and run infrastructure at the same time as your microservices or your application. I hope that gives you a little bit of overview as to the different operation models. So as you can see, Kubernetes is not Kubernetes. You can actually do everything from scratch all by yourself. You can use a public cloud provider offering. You can use a container management platform that you license, or you can use a fully managed solution that is built on top of open source, but at the same time is managed by people that do that around the clock, and that can easily focus a larger amount of people on and experts on a certain problem to get it fixed, so you can actually return back to normal very rapidly. Now, if you actually then think about how you actually want to balance or how you want to participate in this discussion about Kubernetes, and I don't know what your experience has been so far, but actually I rarely see a very active role of a product owner. So the product owner actually comes up with an idea of looking for an alternative and suggesting, but the decision typically is taken by the software architect primarily, or the infrastructure team. But these are different, let's say the 4 different stakeholders we typically see in an environment, and I think it's very important for the product owner to know what is important for these different stakeholders, if they not already know it, but just to pinpoint it again, and then understand how you can actually support the different individual stakeholders in their decision process, and and also be heard yourself in terms of what is important and why things are important to you as a product owner. So if we actually look at engineering, software engineering, so the software developers, they actually naturally want to be in full control of the platform, because then they actually can make changes and understand and especially fix things very, very independently. So that's something that is definitely a prerequisite from the engineering side. They might not always want to do it. They expect it should work, but in reality, things just don't work always. So you actually being able to go in and fix it, especially if you've got the skills, is something that that actually helps the engineering team to get on with their tasks. And so they actually want access to the logs and the code, and naturally to make changes, which is something basically all our developers actually fully agree with. They actually are in constant. So basically, we give customers access to our. We actually don't have first, second, and third line or third level support. They actually get access to the developers directly, so the developers fully understand what the customer is trying to do and what's not working, so they can then immediately go in and fix it, because it's a lot easier to fix naturally a solution you've developed yourself rather than one that you actually have licensed or that you actually don't work on actively and need to figure out why it's not going the way it is. So that's one aspect is being able to actually go in and being able to be in control. The other aspect is engineering will always try to automate things, which is natural. That's basically the whole idea of software engineering. So they actually will also want to to benefit from an automated CI/CD pipeline where you can then push things into production very easily, into test very easily. Make sure that you actually have a good test system that then allows you to then get and capture the errors upfront, so you can go in and fix it before you push it live. But the other thing is also that engineering typically is also quite self-sufficient. So if you actually tell them they should run Kubernetes, they actually are quite happy, may be quite happy about it. It's a new technology. They love playing around with things. That's the curiosity that we actually love about software development developers. At some stage, you might find they become the solutions become pets. That's a concept that you typically see a lot in the DevOps environment, where you've got pets versus cattle. Pets is animals you take care of. Cattle are the ones you just replace. The concept of DevOps, and especially Kubernetes, is basically the concept of cattle. You basically, if you've got a pod, if you've got a cluster that doesn't work anymore, you get rid of it. You replace it completely. If you actually do an upgrade, you don't try to fix your node, but you try to replace it. So basically, these are elements where you just need to be a bit careful that if an engineer actually has developed something and knows where to fix it, it actually becomes very difficult to move them to another system unless the pressure is very, very high for them themselves, and they actually acknowledge that it's getting too difficult. If we actually go to trade shows that are engineering heavy, every person we talk to says, no, everything's running fine with Kubernetes. And then we actually talk about the issues we found in the last while, and they all say, yeah, we ran into it, and yeah, I took some time to fix it. So that's a typical experience we actually have. So the level of pain is always a bit different. If you have worked on something and got used to the level of pain, rather than if you actually look at it from the outside for the first time. The other stakeholder is the software architect or project architect, who basically wants to find a good basis for a very reliable solution. Naturally, the basis infrastructure needs to be reliable for that, especially in operations under pressure. You might have, let's say, scaling issues and other things. So load tests that you want to run. So that's something that needs to be secure as well. You actually want typically to support the implementation, so the software developers as much as possible find applications or components on top that you can reuse that would help get you to a very stable system, also over time. It actually will change, but the more stable it is, the easier it is to plan. So that's where basically the architecture folks will focus on. Also very self-sufficient. So basically the need for external help wouldn't be considered that strongly, because very knowledgeable people, typically software engineering that actually are very successful, may end up as architects, software architects, senior software architects, because they actually have seen and designed so many applications themselves. They actually might not see the need for external help, because basically they know that whatever they touch, they can do it, and that's a great capability. But it actually also just something to watch out for. It might not be apparent for them that you might want to consider using the engineering folks for the differentiating tasks and not for the commodity. So for things that really provide value. So that's something you just need to watch out for. And also the decision typically is very focused on technology. So there might be this feature or that feature. Typically, to be honest, this is a space that is developing really, really rapidly. There's nothing that cannot be done. There might be some solutions that might be more adept for use cases. Let's say you actually want to run on Ali Cloud or whatever, then in China, then that's something where you actually everyone would be able to install it somehow there, but you actually will need to have some knowledge in the background around, let's say, China. So if we run, for example, our installation for Adidas in China, we actually also had to learn that internet speed actually suddenly drops dramatically at 10 o'clock at night. So if you actually want to do upgrades, you actually don't do them around 10 o'clock at night there. You try to bring the images over throughout the day, so you can then apply them locally overnight. There are a couple of things that where basically where it makes sense to focus on certain technology decisions, but it's typically, at least I haven't seen too many that make sense to decide to go with one solution or the other. The next aspect is the infrastructure team, typically developed from the operations team. Then this company decided to go cloud, and the infrastructure team basically became then the cloud infrastructure team, setting up new platforms, which makes total sense, and they actually could then basically provide the Kubernetes services to the whole company. Makes sense in principle. So far, many times, actually, if I just think of a large telecommunications provider we did a tender with last year, basically the tender was unbelievably long. Tons of pages, going through all the requirements, understanding them, lots of effort to actually really understand what they're trying to do. And eventually they stopped the tender because they found that either the vendors that participated didn't provide what they were looking for, and or they were providing it at a cost which they weren't interested in paying. So and I think that's the typical dilemma of an infrastructure team. If they actually build a cloud platform or a Kubernetes platform to be used, they actually will tend to try to get as many projects onto that as possible. But for that, they actually need a platform. So you basically start developing a platform without a project on team, and that's something that's impossible. So you can't, without, let's say, starting with your first use case, you can't build a platform that then will be used by all different projects, because it either gets crazily complex or is so far from being usable or even operationable that it's something that that actually puts the infrastructure teams on a lot of pressure. So they actually will typically try to resell the platform they have developed. It might not really fit your project. You might end up having many elements that you're missing. It actually becomes inherently complex. The more you develop it, that's where the pet aspect comes in again. And but the infrastructure teams are not those that then, let's say if you look at Zalando, I think they had 40 people setting up or developing the platform for them, the Kubernetes platform, over 1.5 years. That's a luxury that hardly any infrastructure team typically has. So the resources are quite limited, and the support they actually could give to the teams, which is the knowledge about cloud native technology and how to use how to make best use out of the infrastructure, is something that they actually then can't deliver, and that's so it's a very difficult situation. So their goal is definitely to make it reusable, to make it efficient for the whole company, which is fully understandable and actually makes total sense. If you've got standard use cases like, let's say, SaaS products that you need to run, then that's absolutely a very valid use case. It depends on your project if that actually is the best possible solution, and that's where you need to watch out for that the engineering and architecture teams get what they actually are looking for. And as a product owner, naturally, you try to get your teams working on the things that provide most value. typically, from our perspective, it's not Kubernetes because it's a given that you actually use it, and it's widely available. So all your competitors can use it very readily. So that's nothing you actually should focus on. And having your team focus on it makes least sense. So you might want to talk to an infrastructure team or talk to external partners to take care of that. It's often discussed or viewed as a technology decision, which is something that I fully disagree with, because the majority of tasks will come and cost will come from operations, and you need to basically then take a build versus buy decision, which is someone runs it for you, or you actually run it yourself, and that's a discussion that product owners, in my point of view, actually need to take a more vocal role in. So to express their interest and make sure that they actually don't end up losing development speed due to the underlying someone managing the underlying technology that can't work on their features and their stories. Good. So naturally the limited knowledge, but that's why you're all here. So I'm very happy to take you through these slides. Probably just in the interest of time, I'll just skip over these slides. So basically, you've got certain elements you need to watch out for to satisfy the different needs I spoke about of the different stakeholders. One is naturally the technology, and one is the other is the operations side. If you've got open source technology, you can be sure that you're not locked in, so you can move your workload from one vendor to another, and that's where you basically want to make sure that you've got the ability to execute also in the future, not only now but also in the future. Multi-cloud environments, very important if you actually have different, let's say, regional requirements, or if or security requirements or other requirements that require for you to do multi-cloud. But the most important aspect here is also the portability. So being able to move from on-premise to the cloud and to the public cloud and back again to the private cloud is just something that actually will help you evolve your application without having to worry too much about the infrastructure. Upgrades and security fixes is a given. That's something you need to take care of. That's where open source is not free. It's all a community effort, and you actually need to go in and make sure that you actually contribute to it, either by supporting a vendor that actually works on these fixes and identifies them and works on the development, or you do it yourself. Automation is very, very important, especially if you actually run several clusters. Then it becomes even more important. We run Kubernetes on Kubernetes to make sure that we basically have the same principles of automation included in our management of Kubernetes. That's where we built 6 years of automation into the platform to make sure that everything actually runs as smoothly as possible. And then on the operations side, you need to make sure that you cover the 24/7 shifts. You make sure that you actually have a knowledge transfer from, let's say, the modern technology into your team, and then from the team into your development teams, so that actually all the principles are used. And then security is a given, something that we basically require you to do role-based access and pod security policies. So these are elements that are mandatory, and that's where governance comes in. And and then a very important aspect, often forgotten, is that whenever you run into an issue, you can resolve the issue, but that doesn't mean that the problem doesn't appear again. So if you have a typical error, for example, we actually had under Azure, is that there are too many outside connections, and that's a problem that you can easily resolve by increasing the limits. But yeah, it doesn't, you will always run into the same issue again. So that's where you need to do post-mortem analysis, and that's what we do for our customers, make sure that we understand what the root cause analysis is, and then we are then able to fix it permanently for our customers. So as a summary, it's very important to understand the drivers. So what problem are you trying to solve with Kubernetes, and also why actually are we using a certain mode of operation, and what is the motivation of the stakeholders? Find that out, understand as much as you can, so you can then make a much better decision. Also understand the budget implications, so you can use an external team, but also an internal team. If the expectation is a lot higher for if the bigger your internal team, then think twice about that. Open source is not free. You will have to invest in it, either in support contracts and other things. So, there will be a cost, and if the cost is your software development resources, that's pretty sad, because that takes you further away from your goal. Involve experts. That's only my recommendation. Is you actually can't discuss with software engineers and architects as a non-techie, understanding all the things that will happen in reality. I experience that myself. Whenever there are, let's say, technical discussions, I get someone like our solution engineer into the call, because they actually can easily exchange knowledge, and that's something that is very, very helpful. To just raise the expectation. What are the other possibilities to reach the goal? So what are you trying to do, and what are the ways of reaching that? And then naturally plan for the future. So don't think about now only, think about what will happen in the future. Make sure that you can reuse components. Like if you're actually on a certain cloud provider and use the monitoring of the cloud provider, and you want to switch to another cloud provider or on-premise in the future, that's where you actually have difficulties. So yeah, from that, rushed at the very end, quite sorry. But hopefully that actually was very interesting. And actually I would like to open for questions now, if you've got still time. If not, then send me an email or give me a call, and I'm more than happy to answer your questions.